Alrighty, 11:02. We're going to get started. And I just wanted to give a quick intro to our wonderful presenter, Ken Pillonel, who is obviously very much human, but also a one-man plastics factory. So just a little bit of housekeeping. Like I just mentioned, if you have any questions for the end of the presentation, please put them in the Q&A portion so that we can make sure we take a look at them and have Ken answer them at the end of the presentation. We're going to talk through Ken's amazing application, his product, his business, and how he got there with our Formlabs 3D printers. And then we'll answer your questions live. For one more housekeeping things, please engage in the poll. It really helps us make sure that you're getting the information you need. So if you could just answer a couple of those poll questions, like what you're currently using 3D printing for, or what kind of application or industry you're in, it's super helpful to us. And hopefully that means we get you more specific, applicable information for you in the future. All right, with that, I'm going to hand it off to Ken. Thank you guys so much.
Thank you, Olivia. So if you haven't seen my product, it's an AirPods case. So same as you have phone cases that protects your phone. Well, it's the same for AirPods, what I have here in my ear, but they have a special twist. They actually convert the old Lightning port to the more universal USB-C charger. And so that the goal here is to kind of give a second life to your device, and so it would last longer. And so I'm just going to show you a really quick video of what it looks like, the scale of it, and the details, just so you know what we're talking about throughout the presentation. And things like that. I also made this video called the One-Man Plastics Factory. I would recommend watching it after the presentation if you haven't, because today I'm really going to try to not repeat what was said in there and try to give you even more technical information. And so the plan for today, so first I'll walk you through my own process, my thought process to decide if SLS or something else was the right approach to create this product and bring it to market. And so the idea here is that I might give you arguments that you haven't thought about, and it might influence your own decision later on. Then we'll see what you need to get started. And then I'll give you tips that I learned the hard way while developing and also producing all those plastic parts. And at the end, we briefly talk about post-processing and what's on the horizon and what I'm excited for next. So why SLS? You have an idea, you want to create a product, and it's made of plastic. You need to decide before even starting designing it, how are you going to manufacture it? I think that's really important. And well, I started with the cheapest and the cheapest method that I knew, right, which is FDM printing with the filament. And I told myself that it wouldn't be good enough for my product, simply because the look and feel, even though I know like people have opinions about, they're going to say my XYZ printer can print better than this and whatever. I get those comments a lot. I feel like it's not good enough for a consumer product that you might sell in a store or something. It just has this, it doesn't have a premium feel to it. Then we have SLA resin. This I use a lot for prototyping. I really like it. The quality is amazing. The resolution, it's the best. But there's a few things that made me not go this route. The first thing is the post-processing that I don't really like. So it's especially like handling the resin and the chemicals, and then disposing of the alcohol you need to clean up this whole process. Like, it's completely fine for prototyping, but just me personally, I didn't see myself doing this every day for weeks for prototyping, right? And then like I think the biggest point here is the supports, which you also have with FDM printing. But on my use case, on the cases that you can see here on the right, there was no way to orient my parts so that support wouldn't be visible. So don't get me wrong, like they leave very small marks, but it's nothing crazy. Just if you have high standards, and you can still see little dots on the surface of your part. And so if you want to avoid this, then you need to sand it, right? But if I sand it, then the surface texture of the part that I sanded is not going to be the same as where there wasn't any supports. And so that would be a lot of manual labor just to just imagine like the scale. I didn't know this back then, but I had to make thousands of those cases. So if I had to sand thousands of parts and then maybe paint over them, it just wouldn't be possible as a one-man factory, right? And another part is those resins they cure with UV light, right? Or UV laser in the printer, but we also get UV rays from the sun. And so I was a bit worried about the long-term durability of those parts, especially like it's things that go outside. We leave them on a table, we place them on your desk, they get exposed to the sun a lot. So I was wondering, I was worried how they would have held up for a few years, right? And then we have I call them legacy alternatives, but like the main one is injection molding. So that's the process that most of the parts you own on your products, the plastic parts, were made. And well, I didn't go this route because first, I love to iterate and to improve, right? Get customer feedback and just make it as best as I can. And with this, you have to make molds made out of steel or aluminum, and it's very costly to change them or even to produce them, right? I got a quote for my part that we see here on the right. It was about $15,000 just for this part, and I have 3 different parts for each case, and I have 6 different models. So it was like 17 different parts that I had to produce. So if I had to make a mold for all of that, I didn't have the funds to do it, right? And I also saw making a mold as a sunken cost because, well, those products I'm not going to be selling them in 10 years, right? They're going to be obsolete. And so all those funds that I put in the mold, in some years, it's just going to be like a nice paperweight. And so I didn't really want to invest my money this way. Another point is design constraints. So when you make a mold, you have to think about, like, when you make your part for your mold, you got to think about how it's going to actually work. And here on the right, we have a cut-up view of my part, and we see there's inner cavities, there's holes, there's engraved text. And so if I wanted to injection mold that part, it wouldn't be just a simple 2-part mold. It would be actually a really complicated mold with sliders, and so the cost would go up exponentially. And so that means that if you don't have experience with injection molding, you have to spend a lot of time either learning about it so that you can design parts that will work well with it, or go back and forth with your factory, and that's also time spent, and so time is money, right? So it ends up being really expensive to design injection molded parts. Whereas with 3D printing, well, I didn't really have to think about, is it going to work or not? Maybe just some parts if they're really thin, like really thin walls, but otherwise your imagination is the limit, which is great. And so I think it still has a big place in the world of manufacturing, but you need to have guaranteed demand, right? If you're a big company and you know that you're going to sell that many upfront, then I think it's still worth it. And the last part, and this was the top comment on the one-man plastics factory, so I'd still address it. It's ghost shifts. So let's say you hire a company, a factory in China, for example, to produce your parts. And well, it can happen that if you don't have a good relationship with them, or they're not really trustworthy, or maybe they have a rogue employee, well, it's happened a lot that they can actually use your mold in the evening again and punch out more parts, and then sell them to someone there, or sell them directly, and then you have your own products with a different brand that ends up being sold on Amazon or AliExpress. And so with 3D printing, you can actually avoid that and just go quicker, iterate quicker, and be more innovative, right? And the last thing I've considered for my production was urethane casting. So it's kind of like injection molding, but the mold is made of silicone and you inject like a liquid plastic inside. But I didn't go this route because the molds can only last for about 20 to 50 units. And it's very labor and time intensive. So just like you can't open the mold right away, you got to let it cure for a few hours. And this is great if you know you're not going to make more than, let's say, 100 parts or some around this range. If you know you won't have more, then that could be a great way to do it. But I didn't know how many of those parts I would have to make, right? I couldn't predict the demand. But just in case it would be in the thousands, which it was, if I had to go the urethane casting, it would have taken me months to do. And so it's not really a scalable approach. So now it's also fair that I would talk about the drawbacks of SLS, right? Because it's not just positives, and there's a lot of negative comments that I get from time to time. So I thought I would address them too. A lot of people talk about the safety of powder handling. I personally have never felt unsafe. Everything is really contained very well. Even now with the new glove box in the Sift, like you basically never have to interact directly with powder. And the only time where you kind of do, you wear a mask and protective goggles. And I actually like using this process way better than SLA resins, for example. Then they talk about the upfront investment. So of course, those machines are not reachable or affordable yet for hobbyists. But they're still like they're still the ones made by Formulas. They're still the most affordable on the market right now. The way I saw it was that it costs the same as a few molds. So if I had to cast a few molds, it would be the same price as my setup, but I get to get a parts maker for years, right? That can make an infinite amount of parts. And so if my product doesn't work out, when I can just try to make a new one and hopefully make back my investment later. Or it's already been made back. So I was really lucky for that. And I told myself, worst case scenario, which I don't plan to do, right? But I told myself, if I don't make back my investment, I can always try to resell the machine and try to make some of those funds back. Whereas if I had molds, well, there would be just no way to get that money back. Maybe like melt them for the steel, but it would be pretty much worthless. The other drawbacks that come up a lot is plastic finish. So with injection molding, you can do a lot of exotic plastics and colors and textures and surface finishes. And with SLS, you're a bit limited. That's true. I'll talk about that a bit more near the end of the presentation. And the last part is cost per part. So also I didn't address this in the video. I'm going to talk about it now. So let's do that. So here on the right, we have a full build volume. This is what I print. I mean, I used to on a daily basis. Now it's a bit less, but it's the most amount of cases I could pack in one build volume of a print of the printer. And in there's 70 cases. Each case has 3 different parts, so that's 210 different parts. And on the right here, you see the screenshot from the slicer. It gives you all the information about that print. And here I really want to focus on the 2 yellow boxes that I've highlighted here. So total powder and mass packing density. That tells you you want the mass packing density to be as high as possible. So that you use the most powder when you print. And that here it tells me 14%, but I have found that at the end of the whole process with post-processing, when you have your finished part and you have the leftover powder, I was more around 30%. Now that's because first there's some losses in the build around the build chamber, so you have to vacuum those. Then in the sift station, you gotta try to recover as much powder as you can. And I have a really complex shave that's concave like this. So if I go in there with my fingers, it's kind of hard to get all the powder out. And with all that, and by printing a lot, I came up with this 30%, like this double mass packing density for real usage. It will probably be lower for you, but I would just thought about giving really conservative values so that you can see, and like I don't want to seem not genuine about it. So in this print, we used 4.52 kilograms of powder in total. So that's unsintered and sintered powder. If we take 30% of that, it's 1.36 kilograms of powder that's not going to be reusable, right? Right now, 1 kilogram of nylon 12 is at $100. That's the most expensive price, right? There's volume discounts. I think if you buy 4 kilograms or something like that, you get an extra kilogram for free. So you can get 20% off quite easily if you know you're going to print many prints. But still here, let's take the most conservative number. So there's 70 cases in the print, which costs $136 of raw material. If we divide that by 70, that's $1.94 of raw nylon 12 powder per case, which if you're competing on pennies, like you would not look at SLS, but if you're doing a kind of like a more premium product, or you can easily pass off $1 or $2 on the customer, right? The cases here that I make are sold between $30 to $45 or something like that. So the difference between having a 10-cent part or $1.90 part, I could eat that in the benefits, right? It wasn't that much of a problem. But then people ask a lot about electricity, right? You've got all those complicated machines. Surely they must use up a lot of electricity. Well, so I looked into it. I bought a power meter, plugged it in, and ran the full build volume that I showed you before. And the whole whole consumption for the whole print was 5.8 kilowatt hours. Then with post-processing, I've put an estimate because it really depends on how many blast cycles you do, or how much time you spend on the sift. But here again, it's very conservative. It was less than this for me, but I just rounded it up to 7 kilowatt hours in total with printing. I live in Switzerland, so the cost of electricity and pretty much everything is quite high. So I pay about 30 cents per kilowatt hour. I just looked up the US average is 18 cents. So again, here I'll use 30 cents for a conservative value, but that price really depends on what area you live in. And so in total, that would mean that to print all this and post-process it, it costs $2.1, which if we divide by 70, it's 3 cents of electricity per case. So again, here, pretty much negligible. I really don't take it into account when I make my pricing. So for the minimal setup of what you need, I'll glance over it quickly, but I would really recommend getting the Glovebox add-on because it kind of closes the sift. And before I didn't have it, and I was always worried that I would open a window and some wind would come and blow some powder out in my workshop. So I didn't really like that, but they listened to their customers, so they came up with that. That's great. And about the sandblasting, so I started with a sandblasting cabinet. You can get those for really cheap. They're about $200 or something like that. They were great for prototyping, and if you only make a few parts and want to just get them properly, like the sandblasting cabinet is a must. But as soon as you start to do production, I would not try to do it in a sandblasting cabinet. I had to do that last year, and I made one day I had to sandblast 100 parts manually, and just my whole back hurt, everything, like the finish wasn't consistent. It pays itself, so it pays itself off so quickly, just in labor, right? And you do need to get a compressor for that. Here it's a bit tricky, especially if you're in Europe, uh, to find the right one, because I wanted something that I could still move and potentially use with other tools, right? I didn't have unlimited funds. I wanted to use that compressor for other things as well. And so like the overlap between compressor you can move and compressor powerful enough for the fuse blast is quite small. I did find something which was I would say the lowest powered one. It was about, I think it's a 3000 watt compressor, and I would not get anything less than that, and it costed about €1,000. So that's the bare minimum for the compressor. And then I had one tip for shipping. So when you get machines shipped by Formlabs, right? I don't know if it's the same everywhere in the world, but I could choose between plug and play and dock delivery. And so I started with plug and play because I had some stairs that I needed to climb and I wasn't sure how to do it myself. But then I found out that the delivery guys, they just used one of those. We see here a screenshot on the right. It's I'm not sure what it's called. I think electric climber or stair climber or electric dolly, and you can actually rent those for in my area at least for about $50 per day, and so you can save pretty much $2,000 on shipping if you take dock delivery and you rent one of those, which is what I'm going to do in the future. So yes, that was for the setup. Now we actually want to start developing our product, and there's a few things that burned me while I was doing it, and so I thought I would share it. As I said, I really like to iterate quickly. So you get a first draft of your design and you print it and you kind of get a feel of the dimensions, if they work well or not. If you have interlocking parts, also that's good to look at it pretty quickly to fix one dimension. And the first thing you need to watch out for is print orientation. So here on the right, I've got two orientation. One case is sitting on its side, the other one is standing up. I chose to go with the sitting option, so the one on the left, simply because it's got less Z height, and so it will print more quickly than the option on the right. And so that's great. If you want to prototype quickly, it'll go quicker. And once you've chosen one print orientation, it's really good to stick with it throughout the whole development. And in the slicer, you can actually lock the orientation, XY rotation locked or XYZ. I found that XY is fine. It's more like when you start to have rotations along the X or the Y axis that you get problems, but not around the Z axis. And so you've chosen this orientation and you stick with it throughout the whole thing, because if at the end you change it, then some tolerances might be a bit different and the part won't feel as the same as throughout your whole development. And also it won't look the same, right? But it's very subtle, but if you're trying to produce something at a large scale, it's important. And another thing that's important is the print settings. So I didn't think that much about it at the beginning, but then I did see some differences. I started on 2.2, but now there's 4.1 and 5.1. You can also choose custom settings, but I would personally not go there. I think that I've got enough to deal with those settings. I found that now I print everything on 5.1, but it is a bit quicker. But 4.1, it's true that it does, as it says on the screenshot, preserve fine features a bit well. So I had some really tiny details and walls on one part that would not print very well on 5.1. So this part I still print in 4.1 and all the rest in 5.1. But it's also something to be consistent with and not change midway through your development. this I showed in a video, but basically I like to engrave my revision number in the part, because then I just end up with so many so many parts and so many things. It's hard to see visually which one is what, and you can do that directly in your design software. I like to do it this way because it automatically changes the number with the with the file number in the software. But now you can actually do it in preform as well. They added a label feature, so you can do it directly there. And this one also is, so I think this one is not important if you do big parts, but if you do very fine and small stuff, you can actually see a difference quite easily, and that happened to me. If you don't, so you're in your design software and you click export to STL to then import into preform. If you don't choose which settings you use for, it's just gonna choose like the default one. But sometimes if you modify the file in between, it's gonna export differently. So I found that it's good to have the same refinement settings every time. That's the ones I use here. They're meant to preserve fine features, and so you end up with a very large file, but I don't really care about that, right? I just want to have consistent quality and yeah, consistent quality. So you can try with those, see what works for you. I'm just giving those as a baseline, but it's important to always export with the same refinement settings, I feel like. So that was for development, but now we actually want to start producing, right? And there's two, so you want to put a lot of parts in this build volume. There's two ways to go about it. So you put your parts in, you multiply them to get how many you want to print, and then you want to pack them so that they don't touch each other while printing. Here you can choose between auto packing and manual. Auto packing works great. You just select everything, press pack selected models, and it's like magic, right? Everything is packed super nice. I found that for production, if you have the same part that you print a lot of, it can be interesting to try to pack it manually. So that's what I did here for one case height. And actually, I've got this little plastic part that I could fit inside the shell and print it there, and then scale array everything on a z-axis, and I was able to get a few percent better than the auto packing. But it takes time, and that's just because I would print that print file a lot, so I thought it would be worth it. If you have multiple different parts that are always coming, then I probably wouldn't spend time doing that. I would just use auto packing. And that's an interesting one. I would also do one run of a full build of your part before you start production, so at the very end of your development cycle, because it doesn't mean that if you print one height of your part, it's going to turn out the same as if you print a lot of them. And that happened to me. I actually printed my first, so orders started coming in, and I had to print my first full build volume, and half of the part came out looking really bad. Like they had some pitting at the top. So it's like the top surface that's kind of a dip on it. And well, that's not good, right? I wasted half of those. I lost a bunch of material and all of that. And thankfully, so I went on Formlabs' website, and they have this page where you can troubleshoot your print, and it shows you picture, and you can diagnose what went wrong. And I saw there was one section for pitting, and it said, oh, this is fixed in version 5.1 of the print. And before I was using 4.1. So indeed, I switched to 5.1, printed again, and everything was fine. So that's great, right? But you don't want, the problem was then I was on 5.1, and the tolerance of the case, like when you plug it in the AirPods case, it felt a bit less tight, right? So I had to go back to my design and tweak the dimensions a little bit and then print it again. So that's why I still recommend in development to stick with one print setting and try a full build too, so you don't get burnt later on like I did. So now about production schedule. I'm really lucky because I work by myself. So if something ends up late at night, I can just go and turn the printer off. But I do understand that a lot of you here are probably work in an office with maybe you have employees, or you're an employee and you're looking at this, and you it's hard to kind of manage the schedule, because it's not like injection molding where the parts come out straight away. With printing, you got to plan a little bit. Prints take hours, right? So I usually start my prints in the morning and they end up in the evening. I was also thinking at first, like, hey, okay, the electricity is cheaper during the night than during the day, so I should be printing during the night. But as we saw before, the electricity costs are really irrelevant here, I think. So then now I just print during the day, because I like to have the peace of mind that at the end I can go see how it turned out. I never had any problems, right? But just for the peace of mind of not showing up to the office on the next day and what happened to the printer, right? And also I was wondering how much electricity it pulls when it's not printing, because you can hear a fan, like it's quite it looks like things are happening in there, and it just pulls about 100 watts when it's idling. So if you leave it overnight, let's say 10 hours, that's 30 cents of electricity. Again, I didn't see that as an issue. And so here's an idea. If you work in an office and you say, let's say you have 9 to 5, like standard 9 to 5 working hours, you could, instead of do a full build volume, you could do a bit less, like we see on the left here, and start this at 9 a.m. It lasts for about 8 hours. So at 5 p.m. it would be done. And then if you have a second build chamber and I would say an extra 2 powder cartridges. So the powder cartridges you place on top of the printer and it releases powder in the printer. You need those because the printer can only hold about one full build volume of powder, not more. So you would need to refill after that. And so at 5 p.m. when the print is done, you quickly swap the build chambers, you put the other one, and then you go home and it does the full build volume during the night. So that would be great to optimize the throughput of your production while keeping normal working hours. For post-processing, so this is a step I still haven't found the best solution. I found that it was a lot of manual work for now, but I've seen some other people and I've tried it to use power tools. I think it's important to use a brushless motor for safety, right? But I'll try to show this in another video. I haven't found the best brush for me yet, simply because I had this special part with a concave area. But yeah, just using a power tool could save you a lot of time. And then the last part, so the blast, you put the parts and it blasts glass media on it just to have a really nice finish. Also, this came out really recently, I think a few months ago only, and I didn't find much information about, it might have changed now, but when I started, it wasn't clear, like, should I put all the parts, the 210 parts inside and just hope that they clean properly? So I had to run a few tests and see what works. I found that, so you can either put everything and just increase the blasting time, but I found that that wasn't really worth it. It was probably better to separate it into different cycles. And so what I do is I do 3 different cycles for my full build volume. I do the first one, let's say it's the parts highlighted in blue here. Then I do the second one, the parts in gray. And actually, you see this screenshot on the left, that's the bottom part of the shell. And we also have this little plastic part that I was telling you about before. And so this one has really fine features where I put tiny metric nuts inside, and I can't afford this to be not cleaned properly and still have some unsintered powder. So I actually separate them and I do a third cycle with only those tiny parts, simply because I found that they could get stuck inside the cases and then it wouldn't clean properly. And so I think what I have to say here is that it's better to separate the cycles. I do 15-minute blasting time times 3, and also separate if you have big parts and small parts, maybe not have them together, just to get consistent results and not have any leftover powder. So what's next? I mentioned that, we still have this gap with injection molding where you can't do exotic surface finishes or colors, but I'm really excited because, well, Formlabs just came out with this white powder, which I will be showcasing very soon. And with this, you can dye them with normal dye that you use for clothes. And so you can start doing some really interesting things and like really try to get away as much as possible from this SLS 3D printed look, the dark gray look that I personally really like, but I see that it's not everyone's cup of tea, right? And so this, coupled with the polishing unit that's also available in the Blast, I think we're gonna start to see some really interesting new products and innovations in the space. And so I'm gonna do another webinar in a few months, maybe at the beginning of the summer. I'm not sure yet. So if you want to see that, make sure to be signed up to Formlabs newsletter or my YouTube channel. And with that, I just show you, like, that's all the parts I'm printing right now. I was telling you how many is there here? 3. Yeah, there's more than 17. That's all the parts I'm printing now. And that was all made possible using those printers, and it's working really well. Thank you very much for listening.
All right. Thanks so much, Ken. That was amazing. Really excited to learn more about your application. I think we're going to move into the live Q&A portion. So Ken, if you want to go over into the Q&A, take a look at those public questions. Feel free to go at will, choose which ones you want to go over. And for everyone else, we'll be sending you the recording in a couple hours. And if you could answer those poll questions, we'll be able to respond to any questions that we might not get to today with the best information. So polls are super helpful. Please answer those questions. And Ken, you can take it away and answer all the live Q&A questions in that public box.
Yeah, okay, I'll do my best. So first one I see is, what distances between parts do you find the best? I think the default value is 5 millimeters, but I use 2 simply because, well, I'm cheap, right? I'm trying to get the most powder out of it, and I've never had any problems with 2. I think I tried a bit less, 1.5 or 1, and I started having some overlap between the parts, because I think when it prints them slightly larger, and then they when it cools down, they retract and reach their final form. And so 2 millimeter is my answer for that one. Then, I'm a college student. Is it better to use SolidWorks or Rhino for 3D printing, or do each have their own purpose? Okay, I would say if you're doing engineering work, use SolidWorks. Rhino is more for architecture, I think. But for the final result, I don't think it's going to change much. But I would use SolidWorks personally. Are you? Oh, sorry. This one. Yeah, okay, I think this question just disappeared. How do you keep your workplace clean and healthy hair while working with powder plastic? So, okay, good question too. I think it's great to have them in a separate room that you just open the window from time to time. But even if you don't, which I didn't at the beginning, I have not had an issue with like really everything is closed off and filtered. You can add, if you want, like a, what's it called, like an air purifier in your room, but I have not felt unsafe in this regard. Okay. Hi, Ken. You mentioned Ghost Shift as a financial risk to rule out manufacturing processes versus SLS. Meanwhile, you chose to keep your design open source for SLS printing. True. What is your thought process behind this choice? Yeah, that's an interesting one. Thank you, Anthony. Uh, I think maybe I didn't mention this quickly, but when the issue with Go Shift is that when you pay for the mold, right, it costs the factory to produce it, right? And then it kind of gives them an incentive to get a bigger return on their investment of making this mold by producing more parts. And I do things open source, but I don't think like it doesn't give financial incentives directly, simply because I have the audience and people that watch what I do to really like funnel interest in what I do. Whereas if someone just stole my design, it would be hard for them to get people to buy it, right? So I think that answers it. Does orientation take any factors like MGF? That packing would not be so good on MGF. Well, I have not much experience with MGF, but as I said, orientation does matter, especially on like if you rotate the part in the X and a Y axis. But again, like you wouldn't, if you just print a part one off, you wouldn't see a difference. It's more like if you print a lot of them and you want really consistent result, that I would keep the same print orientation. But MGF, I can't tell you about that, sorry. Do you mix powders regular or not on sift and build units? I'm not quite sure I understand this question, but I do mix the powder in a sift station and I use a 30% refresh ratio. Any plans for producing USB-C cases for Lightning ports iPhone? Yes, so that's coming too. And I forgot to mention it, but it was one of the last slides. And really excited to show you that. I'm working really hard to make it, and it's going to come with colors too. So that's I'm really excited about. The cutaway view shown earlier has what looks like a very thin wall near the USB-C connector. How thin are you printing that area? Good catch. I've got a keen eye. So indeed, it's very thin. I think it was maybe 0.3 millimeters. But the only reason I could get away with it was because it was really supported on the sides, and it wasn't just hanging somewhere, because if you did that and you try to remove powder in a sift or then you put it in a blast, it would 100% break. Here it was because it was held together by every side, and I didn't have an issue with that. But again, I think this is the like the lower boundary of what you can achieve there, 0.3 millimeters. Were you able to achieve a snap fit on the AirPods, or do you use adhesive? So the snap fit is what I was really looking forward, especially for the bottom. And here it works great. For the top, it's really hard to get a snap fit, simply because the curves are really complex and it's hard to model them. But I use an adhesive, and I bought a bunch of different cases before, and they all use adhesives. Okay, I think I need to find questions more related to SLS printing. Well, okay, this one's interesting. Have you had any issues with moisture absorption, discoloration of nylon with regular use of your products? No, actually quite the opposite. So when I ship the case, it has this like dark gray color, a bit maybe on the lighter side. And I have found that after about 2 weeks of use, just by rubbing it with your hands or like keeping it in your pocket, it does absorb a little bit of moisture, but that's like the nature of sintered products, right? But it actually makes the opposite. I think it makes the part look nicer. So it gives it kind of like this polish finish while like rubbing on other surfaces, and the color gets a little bit darker. So I don't know if you count that as discoloration, but I actually like the darker look better. So I think it kind of ages like fine wine. That's my opinion. I lost that question. Do you have a specific humidity range you work in? I was told this is more critical than MGF. No, I have not had any issues, not controlled. I mean, it might be different if you live in a very humid area, or but yeah, I did nothing for that and haven't had any issues. Can you talk a bit more about the coloring options? I mean, I'll do a second webinar on that because I think we could, and I don't have much experience yet on that, but I will in a few months. But basically, there's this new white powder that you can dye in water with some coloring, and that could really open up a lot of new options. Thicker walls would be more than 2, right? I guess you mean 2 millimeters. How hot does the bed get? Well, this is all set up automatically. The bed, I think it prints at 180 degrees Celsius, and then you need to let it cool down at the end. And thicker walls, yeah, I mean, it really depends what kind of product you're making, right? But I guess after 2 millimeters, it's already no, it's 2 millimeters is still thin, but when I meant thin walls, I meant under 1 millimeter. So I see there's one question about the electronics. I'm not here. Like you can, I'll probably do another live stream or something, but today please keep the questions for 3D printing. And any meetups, not yet, but that's the first virtual one. So I'm already happy you guys are here, but I'll definitely plan to do some in real life. I'm most concerned with the health hazard of the powder when removing and install the embed chamber in a printer and while filling the hopper. Do you use any respiratory protection while doing those? Yeah, for sure. That's what I said. Like everything is really closed off and filtered. The only time where you could be interacting with powder is like when you remove the build chamber. And for this, I would definitely get a mask and some goggles. Like I think the only problem I've had, if I have to be really transparent, is once when I do the blast cycles. One time I opened the door and I put my head directly inside to pour the parts, and I wasn't wearing goggles. And actually, I think maybe something got into my eye and it kind of started scratching. So now I learned my lesson. Every time goggles and masks, every time you have like open air. But otherwise, when it's printing or doing its job, never had any problems.
Ken, I was just looking through some of these questions, and I actually wanted to ask you if you could sort of clarify some questions about nylon 12 particularly. So in terms of like mechanical properties and material properties, how have you found that the nylon 12 powder compares to like an injection molded nylon that you might get as part of a normal consumer product?
Well, I don't have that much experience with injection molded parts, but I could say compared to other like 3D printed parts, especially like the mechanical properties are really, they're really great in every direction, right? Compared to FDM printing, where like it's printed by layers like that. I found that nylon 12 was like a great material, super tough to break. I have had a few that broke, but it's mainly because I'm trying to push the boundary and making very, very thin walls, as thin as possible, actually. But otherwise, also in terms of SLS printing, it's the easiest material to print in the whole range that you have, right? It's I've, as I had the pitting issue that I mentioned, but otherwise everything is really easy to print, and it's not a very difficult material, I would say.
Mm-hmm. And sort of following up with that, I think Scott Russo had a couple questions just about brittleness, flexion, kind of surface finish of the parts. How, Scott, if you have any more questions about that, we can definitely send you samples so that you can test it against like a more stiff option like nylon 11 carbon fiber powder. But Ken, have you found that the cases exhibit any type of flexion? When they don't have an AirPods case inside them, are you able to sort of squeeze the case and watch that deformation happen and then bounce back?
Yeah. Do I have one here? I don't know if I have one here that works well, but I mean, I can show it right away. Like, I've never. I'm not sure if I would say I could stand on it with that gap, right? But otherwise, it's really strong. It's really strong.
Mm-hmm. And Evan had a question about high impact resistant materials, also available from Forum Labs. For SLS specifically, we definitely have impact resistant materials. I mean, TPU is probably the most impact resistant because it's, a rubber, so it's not going to break when you drop it. But in terms of like stiff, rigid SLS powders that are also impact resistant, I think our best is probably nylon 12 tough, which a lot of the same material properties as nylon 12, obviously, but a little bit better elongation of break and flexural modulus. And then Ken, I don't know if you wanted to answer this question from Gaetan about just pushing the boundaries of the design guide specification. I see, Gaetan, you already have a Fuse 1, but just sort of playing with orientation. Have you found that any one orientation in particular affects material strength, even on thin features?
I would experiment with this. I can't give him a concrete answer, but I'm looking at the question now, adding elements to them. Yeah, I mean, if your design allows it, you can definitely add like supporting walls or things like that to make the part stronger. But yeah, any tips? I think my tips are just trial. Like, you need to, and that's what's great if you already have the Fuse one in house. Try different options. That's what I said also with the revision numbers. Sometimes I do the same, but for like thicknesses, and I try a bunch of different thicknesses at the same time. I print all of them and I see what works best, what's stronger, and yeah, that's great to iterate. Yeah.
I actually wanted to ask one more question as well, just about total post-processing time. We went over it definitely a little bit, and I know it factors into your sort of labor cost calculations, but how long do you think you're spending in the sift for a fully packed build chamber? And then how long are you blasting and polishing that build for as well?
Yeah. So I would say I spent about 45 minutes, not taking into account breaks, but this is too long. I want to bring that down. I think I can bring it down. So this was manually without any power tools. This is why I mentioned the power tools. And it could take people way less time. It's just my case is concave, so I've got powder stuck inside the case that I need to try to get back, right, to maximize the amount of powder that I can reuse. So for that, it was about 45 minutes, but really I want to bring this down. And for the blast, I do 3 cycles of 15 minutes blasting time and 5 minutes cleaning time. So that's 20 minutes per cycle. And so it takes 1 hour, but it takes 1 hour where I can do other things, right? I can answer emails, develop new products. It's not me working for 1 hour. So
Right.
yeah.
All right. Well, I think we're going to end the webinar here. Ken, I don't know if you wanted to tease any new upcoming products or ideas coming up, but we will definitely be tuning back in with the webinar format for people who have more follow-up questions about new ideas as well.
Yeah. So as I mentioned, colors and iPhone, that's what I can say. And if you have more questions, you can try to shoot me a message on LinkedIn. I'll try to answer to everyone. I've got a big backlog for now, but I'll do my best to get back to you if I haven't answered, because there's still more questions. I haven't read the chat either. So yeah, feel free to reach out and I'll do my best to get back to you.
All right. Well, thank you to everyone who has attended. We will be following up with the recording of the webinar shortly to your email. And please feel free to reach out if you have anything else you'd like to ask us about the Fuse, Ken's project. We'll make sure to get back to you with the right answer. All right. Thank you, everyone. Take care.
Thank you.